In these past few days, the weather news in India has been dominated by visuals of the city of Bengaluru flooding. Intense rains which started Sunday night and persisted through Monday morning led to a deluge as high levels of water was dumped on a city starved of drains and emptied of natural water bodies. The flooding was immediate and intense, leading to people wading through the waters within just minutes after the rain began. Large parts of the city were inundated and the rains were pretty strong for this city. In just 12 hours, Bengaluru received 13.16 centimeters of rain according to the Meteorological Office. Many areas were under knee-deep waters and even up to waist level. Low-lying areas were completely submerged with stranded residents needing to be evacuated by tractors and boats. The city came to a halt on Monday. But what caused the flooding? Was it the rain? Was the rain more intense than average? It turns out, yes, the rains were more intense than average, but that is not what led to the flooding. The intense rain was brought about by two main atmospheric dynamics: the larger climate pattern of rapid warming year by year, global heating, and the more localized weather pattern over the city of Bengaluru, which exacerbated the rains that particular night. But the flooding was entirely because of bad infrastructure, lack of drainage, and the loss of natural water bodies. Historically, Bengaluru receives about 970 to 990 millimeters of rain annually, and it is primarily subject to evening showers throughout the second half of the year mainly. The wettest months of the year are August, September, and October, and the annual rainfall from 1981 to 2010 was 986.1 millimeters. This year, the city already has received 1,466 millimeters. The city of Bengaluru receives moderate rainfall this time of the year in September. In fact, the city has indeed received more rains than it did on Sunday in September at two different times in the past. It received 18 centimeters in 1988 and 13.23 centimeters in 2014, both a little higher than this year's rains. But both these times, the city did not flood this way. During monsoons, Bengaluru receives rain when the monsoon activity is subdued. Subduing or weakening of monsoon in pulses during an active monsoon season is a normal occurrence due to atmospheric wave patterns. During active monsoon conditions over the rest of the subcontinent, there are strong westerly winds blowing from the west. During a break condition in the monsoon season, these westerly winds weaken, often becoming comparable to the easterlies. It is during these break conditions that the city of Bengaluru receives more rain because of where it is geographically situated. On Sunday evening, the changes in these wind patterns trigger the formation of what is known as a wind shear zone over the city. Shear zones are where there are winds moving in opposite directions at either ends of a region, either east or west or north and south, leaving a kind of neutral zone in between. On Sunday, Bengaluru had westerlies to the south and easterlies to the north, and the city itself had a lot of humidity in the atmosphere because it's monsoon season. All of these conditions led to atmospheric instability with weak winds but increased localized convection, which eventually resulted in excessive rainfall. But these shear zones form quite frequently. They are a part of normal weather patterns. They are not unusual. And the rainfall also was not really an anomaly. It was excessive, but it was predicted by the IMD, and experts say that it is very much within the range of expected rainfall. In other words, it was not a freak weather event or an extreme weather event. And we saw that even in the past, at this time of the year, Bengaluru has faced worse rains. However, the city did not flood earlier, but it did this time. Water bodies in the city have been degrading steadily. There has been unchecked urbanization, and most dangerously, a majority of the numerous natural water bodies and lakes around the city have disappeared and have been lost to construction. Concerned citizens have been consistently raising alarm over disappearing lakes and reduced percolation of rainwater into the ground. In 2019, Bengaluru's civic body announced that it planned to remap parts of the city after satellite images just revealed exponential urbanization that the authority was not collecting tax from. It is this lack of drainage and reduced percolation of the rainwater into the ground that led to this year's floods. However, it is also imperative to remember that climate change and the ongoing global heating will worsen every weather event. Rainfall in various parts of the country, in fact in all parts of the globe, will become more intense and its effects would worsen with more dramatic consequences. A warm atmosphere evaporates more water and holds on to more precipitation, thus dumping large volumes of water with extreme intensity in very short periods of time. This is how rainfall patterns are going to be moving forward, and they will lead to flooding, flash floods, landslides, damage to infrastructure, and more. We are now already aware of this. Bengaluru's rainfall is consistent throughout the year but doesn't come to the scales of Mumbai, Chennai or Kolkata. The average rainfall between 1981 and 2010 in the city was 986 millimeters, but since 2010 it has been going up. 2010 to 2011 saw an average of 1,146 millimeters. We know now going forward that the rains will worsen in all parts of the country. These rains are only expected to get more intense as the years progress. Meanwhile, our infrastructure, in fact, throughout the globe, the infrastructure that currently exists all around us is not set up to work for the future. The changing climate conditions change the maximum extremes at which our roads and bridges and power grids and even buildings operate. As extreme rains increase, along with unchecked and unplanned construction without facilitating water absorption into the ground, Bengaluru is ripe for increased flooding with every cloudburst or even just above average rainfall in the future.